The star Betelgeuse, a red supergiant very far away arranged in the star grouping Orion, has long fascinated cosmologists and stargazers alike due to its sheer size and splendor. If Betelgeuse were placed where our Sun is, it would expand out to the orbit of Jupiter, an affirmation of its titanic proportions. Despite being located approximately 642 light-years from Earth, its enormous size makes it one of the brightest stars visible to the naked eye. However, in recent years, Betelgeuse has exhibited unusual behavior, including unexpected dimming and brightening cycles. Many experts believe these fluctuations indicate that the star is approaching the end of its life. Renowned physicist Brian Cox recently made a striking statement suggesting that Betelgeuse is on the verge of a catastrophic explosion potentially occurring within the next 14 days. This event, known as a supernova explosion, will mark the end of Betelgeuse's life. However, it will also provide an unprecedented opportunity for scientists to study one of the rarest and most powerful phenomena in the universe: a red supergiant on the brink of explosion. Betelgeuse is classified as a red supergiant, one of the largest and most massive types of stars in existence. It has been a key focus of astronomical research for many years, but its recent irregular changes in brightness have fueled speculation that it is preparing to go supernova. When a massive star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, triggering an immense explosion. This process releases an enormous amount of energy, radiation, and stellar material into space. The impending explosion of Betelgeuse is expected to be a Type II supernova, a specific category of stellar explosion that occurs when the core of a massive star collapses. This core collapse will unleash neutrinos and radiation, creating a shockwave that will obliterate the star. The explosion will be so bright that it may be visible from Earth without the aid of telescopes, possibly even outshining the Moon in the night sky for weeks or months. While a supernova of this magnitude could be devastating if it occurred closer to Earth, Betelgeuse is far enough away at about 642 light-years that it poses no direct threat to life on our planet. The explosion will, however, be a historic astronomical event, reshaping our understanding of supernovae and cosmic phenomena. A supernova is one of the most remarkable events in the universe, releasing more energy in just a few seconds than the Sun will over its entire lifetime. Betelgeuse's explosion will not only be a spectacular celestial display, but also a pivotal moment for science. Scientists are eager to observe this event using ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to collect as much data as possible. When Betelgeuse explodes, it will emit a wide spectrum of radiation from visible light to gamma rays. One of the most critical aspects of the supernova will be the surge of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the visible light from the explosion due to their ability to pass through nearly anything unimpeded. Observatories such as Japan's Super Kamiokande and the IceCube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, offering scientists an early advantage in observing Betelgeuse's final moments. The birth of heavy elements and cosmic impact. Beyond its astronomical significance, the explosion will provide essential insights into the formation of heavy elements. When stars explode, they create and disperse elements like iron, gold, silver, and uranium, the building blocks of planets' life and galaxies. Betelgeuse's supernova will offer a real-time view of this process, deepening our understanding of stellar evolution and the chemistry of the universe. Though the supernova itself is not expected to harm Earth, it will interact with our planet's atmosphere and magnetic field in interesting ways. The influx of cosmic rays and charged particles could intensify the northern and southern lights, extending their visibility to lower latitudes than usual. While these cosmic rays might have minor effects on satellite communications and electronic systems, scientists expect these disruptions to be temporary and manageable. A rare celestial event visible to all. One of the most thrilling aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks or even months, it is expected to be the brightest object in the night sky, possibly even visible during the daytime. This celestial display will captivate not only the academic community but also amateur astronomers and the general public, rekindling global interest in space science and exploration. For centuries, Betelgeuse has been a defining feature of the Orion constellation, and its eventual disappearance will serve as a poignant reminder of the transient nature of the universe. In many cultures, such cosmic events have been interpreted as omens of change. Its explosion may evoke a mix of awe, fear, and wonder as people across the world witness the death of a star. A gateway to future discoveries. Scientists are also interested in Betelgeuse's supernova as a potential gateway to unraveling some of the universe's greatest mysteries, including dark matter and dark energy. These enigmatic forces are believed to comprise the majority of the universe, yet they remain poorly understood. There is a hypothesis that supernovae, like Betelgeuse's, could provide critical clues about the nature of dark matter. Some scientists suggest that weakly interacting massive particles, WIMPs, a leading candidate for dark matter, might interact with the energy released during the explosion in detectable ways. If such an interaction is observed, it would be a groundbreaking discovery. Similarly, studying the light and radiation from Betelgeuse's explosion may offer insights into dark energy, the mysterious force driving the accelerated expansion of the universe. A cosmic laboratory for science. The explosion of Betelgeuse will serve as a cosmic laboratory for studying how massive stars live and die. Scientists will closely monitor what remains after the explosion, as a neutron star or black hole may form at its core. Additionally, the shock wave from the supernova will travel through the surrounding gas and dust, producing a luminous spectacle that reveals the elements synthesized during the explosion. This will help scientists understand how heavy elements disperse and contribute to the formation of future stars and planetary systems. Some researchers also anticipate that Betelgeuse's explosion could generate gravitational waves which would be detected by observatories such as LIGO and Virgo. A moment for humanity. The upcoming explosion of Betelgeuse will be one of the most significant cosmic events in recent memory. It will not only provide a wealth of scientific data but will also astonish people worldwide. As we prepare for this historic event, the world will watch the night sky, awaiting the moment when one of the universe's most powerful forces erupts into view. For both scientists and stargazers, Betelgeuse's final act will be deeply inspiring, a reminder of the endless wonders of the cosmos. Once Betelgeuse goes supernova, its explosion will not mark the end of its impact on the cosmos. The event will leave behind an aftermath that will influence surrounding space for millennia. Astronomers will closely monitor the supernova remnant, a vast cloud of gas and dust expanding outward from the former star. This cloud will contain newly forged elements which may one day contribute to the formation of new stars, planets, and even life. A neutron star, if the remaining core is between 1.4 and 3 solar masses, it will collapse into an ultra-dense neutron star, a city-sized object with a gravitational field billions of times stronger than Earth's. This neutron star may emit pulses of radiation, becoming a pulsar detectable across vast distances. A black hole, if the core exceeds 3 solar masses, it will collapse into a black hole, an object so dense that not even light can escape its gravity. If Betelgeuse does form a black hole, it will be one of the closest known to Earth, offering a rare chance to study these mysterious objects up close. Scientists will use instruments such as LIGO, Virgo, and the Event Horizon Telescope to detect gravitational waves or potential emissions from the core collapse. If a black hole forms, it might produce X-ray bursts as it interacts with surrounding material. The cosmic legacy of Betelgeuse. Though its death is imminent, Betelgeuse's story will continue to unfold for centuries. The supernova will be a landmark event in astronomical history, helping scientists refine their models of stellar evolution and cosmic recycling. Additionally, the explosion may contribute to the interstellar medium, enriching the Orion constellation with elements necessary for the formation of future stars and planetary systems. Over millions of years, the dust and debris from Betelgeuse's remains may coalesce into new celestial bodies, continuing the cosmic cycle of creation and destruction. A new era of space exploration and discovery. The explosion of Betelgeuse will also mark the beginning of a new era in space exploration. The wealth of data collected will drive advancements in astronomy, physics, and space technology. Scientists will develop better telescopes, more sensitive detectors, and more advanced models to study supernovae and their effects on the universe. Furthermore, the event may inspire renewed public interest in space exploration, leading to increased investment in missions to study distant stars, exoplanets, and cosmic phenomena. Governments and private space agencies may prioritize new space observatories and deep space missions driven by the spectacular reminder of the universe's power and mystery. Final thoughts, a moment for humanity. The impending explosion of Betelgeuse will be one of the most spectacular celestial events in human history. It will provide scientists with invaluable data, astronomers with an unparalleled view, and the public with a breathtaking display of cosmic forces at work. As we prepare to witness this extraordinary event, we are reminded of the interconnectedness of the cosmos, how the death of a distant star can shape the future of galaxies, planets, and even life itself. Betelgeuse's final act will not be one of destruction alone, but of renewal, setting the stage for new discoveries that will expand our understanding of the universe for generations to come.